Are you one of those students who hate memorizing trigonometric formulas? In this lesson, we are going to talk about strategies on how to remember 64 math formulas by just using your magic fingers. Let's begin by labeling our fingers. First, we draw a right angle representing the first quadrant of the Cartesian plane. Then, 0 degree starts at this position and 90 degree angle would be in this position. Then at the middle is our 45 degree angle, 30 degrees is located here, and lastly, 60 degrees at this position. With this as the labeling of our magic finger, we are now ready to find the exact values of these trigonometric functions. First, just for this particular technique, here is the formula. The sine of the angle is equal to the square root of the number of fingers below over 2. For example, if I want to find the sine of 45 degrees, with respect to the 45 degree finger, there are 2 fingers below the 45 degree finger. So using now this formula, sine of 45 degrees would be the square root of this number over 2. So we have the square root of 2 over 2 for the value of sine of 45 degrees. Next, if I want to find the sine of 30 degrees, I count the number of fingers below this highlighted finger, and there is only one. Therefore, sine of 30 degrees would be the square root of 1 over 2, which is simplified as 1/2. If we want to find the sine of 60 degrees, we count the number of fingers below this highlighted finger, and we have 1, 2, 3. So the answer is square root of 3 over 2 for sine of 60 degrees. And for the sine of 90 degrees, we count again the number of fingers below this highlighted finger, and we have 1, 2, 3, 4. So the answer is square root of 4 over 2, but square root of 4 is 2, so 2 over 2 or 1 is the answer for sine of 90 degrees. And lastly, for sine of 0 degree, since there is no finger below this highlighted finger, then our answer for sine of 0 degree is 0. Next, let's talk about the cosine of special angles. For the cosine, here is the formula. The cosine of the angle theta is equal to the square root of the number of fingers above over 2. For example, if I want to find the cosine of 45 degrees, I count the number of fingers above. I have 1 here, 2, so the answer is square root of 2 over 2. For cosine of 60 degrees, there is 1 finger above this highlighted finger, so the answer is square root of 1 over 2, or simply 1/2. Then for cosine of 30 degrees, there are 1, 2, 3 fingers above, so it's square root of 3 over 2. For cosine of 0 degree, there are 1, 2, 3, 4 fingers above the highlighted finger, so we have the square root of 4 over 2, or simplified as 1. And lastly, for cosine of 90 degrees, there is no finger above this highlighted finger, so our answer is 0 for cosine of 90. So we now have these 10 exact values of these trigonometric functions. And all we need are these 10 values in order to construct our unit circle. So position again your fingers at the first quadrant of the unit circle as shown in the diagram, and let's distribute the angles. And now to find the coordinate of this point, the x-coordinate would be the cosine, the y-coordinate would be the sine. So the cosine of 0 degree is 1, that is the x-coordinate, and the y-coordinate is the sine, which is 0. For the coordinate of this point, again, the x-coordinate is the cosine. Since this is 30 degrees, then you look at cosine of 30, that is square root of 3 over 2 for the x-coordinate and 1/2 for the y-coordinate. Using now this pattern, we can now complete the first quadrant of our unit circle. Now to go to the second quadrant, all we have to do is reflect these fingers across the y-axis. So this is now our reflected fingers across the vertical axis. And then let's assign the angles. 90 plus 30 is 120, plus 15 is 135, plus 15 is 150, and plus 30 equals 180. The second quadrant is a reflection of the first quadrant here. So the coordinate of this is the same numerical value as this point, only that we are going to change the sign of the x-coordinate. So from 1/2 square root of 3 over 2, that becomes negative 1/2 square root of 3 over 2, because x is negative at the second quadrant. And continue the process for the rest of the values at the second quadrant. Now let's go to the third quadrant. The third quadrant is also a reflection of this magic finger at the second quadrant with respect to the x-axis. And then let's distribute the angles. And for the coordinate of this point, you just copy these values, only that we are going to change the y-coordinate to negative. So we now have negative for the x-coordinate and negative for the y-coordinate because we are at the third quadrant. And we just repeat the process for the rest of the points at the third quadrant. Now, let's move to the fourth quadrant. Again, we have to reflect this magic finger located at the first quadrant to the fourth quadrant across the x-axis like this. And then for the angles, we have here 270 degrees, plus 30 is 300, plus 15 is 315, plus 15 again to get 330, and then go back to 360 degrees. Then since these fingers are reflection of the fingers in the first quadrant, we will just copy these numbers, only that we are going to change the sign of the y coordinates because y is negative at the fourth quadrant. So for this point, just copy these numbers but change the y coordinate to a -1 and repeat the process for the remaining points. So we have just completed our unit circle using degree measurement for the angle units. So we can test our unit circle. Let's say we want to find the value of cosine of 210 degrees. So 210 degrees is here. Cosine is the x value. So the x value of this ordered pair is -3/2. So cosine of 210 is -3/2. Let's say we want to find sine of 150 degrees. Locate 150 degrees is here. Sine is the value of the y coordinate, and that is 1/2. So sine of 150 degrees is 1/2. Now, let's look at the radian measurement. So we know that in a unit circle, the circumference is 2 pi. So if we assign 0 here, one complete rotation would be 2 pi, and 1/2 rotation is pi. 1/4 rotation is, of course, pi over 2, and 3/4 rotation is 3 pi over 2. So you count this way: 0, 1/2 pi, to 2 pi over 2, or 1 pi, to 3/2 pi, to 2 pi. Then instead of dividing by 2, we divide by 4. So we have pi over 4 here. This is 2 pi over 4, or 1/2. 135 degrees would be 3 pi over 4. Then here is 5 pi over 4. And here is 7 pi over 4. And then divide into 6 equal parts to get pi over 6 here. Then pi over 3 when reduced to lowest term. And continue the pattern until we complete all these fingers. Now for the application, let's say we want to find what is cosine of 4 pi over 3. So 4 pi over 3 would be this point. And cosine is the x-coordinate. And the x-coordinate here is -1/2. So cosine of 4 pi over 3 is -1/2. Another example, sine of 7 pi over 4. 7 pi over 4 is here. You look for the y coordinate. It's -square root of 2 over 2 for the value of sine of 7 pi over 4. So thank you very much, and we hope to see you again in our next video. Thanks for subscribing to our channel. Bye for now.